Hi, my name's Bill Harper. I'm a customer success specialist that works on Splunk AppDynamics. What we're going to do today is talk a little bit about the auto-instrumentation feature of the AppDynamics cluster agent and then show you actually how it works with a small Java application. I'm going to go through a few slides in review to start this out, and then we'll jump over and show you a demo on how it actually works. Here's the agenda, a quick overview and review. What are the requirements to do auto-instrumentation with the AppDynamics cluster agent, a demo, and then some closing thoughts. Just to do a bit of a review, how does AppDynamics provide visibility in a Kubernetes environment? Well, there's three major pieces, really four if you count the operator. We've got the cluster agent, which monitors the cluster event and resources and metrics and health. We have the InfraVis agent. This is our server visibility and network visibility, monitoring the cluster worker nodes. And then we have our application agents, like our Java agent or our Node.js agent, monitoring the performance of Kubernetes applications running within the cluster. What are some of the common use cases for AppDynamics and its integration with Kubernetes? Tracking the state of the cluster resources, monitoring resources and utilization in the cluster, detecting availability and scalability issues, and monitoring Kubernetes applications. Let's talk a little bit about auto-instrumentation. We're going to focus on the right hand of this slide here, auto-instrumentation. And the languages that we can auto-instrument are at the bottom there, Java, .NET Core for Linux, and Node.js. And the way we do this is by using an init container, which copies the agent files into the container that's running the application and configures them so that they can then communicate back to the AppDynamics controller. What are the requirements for auto-instrumentation? You have to have the latest cluster agent, 20.5 or greater, but I would recommend something around the 24.4 or 24.6. Latest cluster agent and operator installed in the cluster and running. At least one application that you can deploy to the cluster that we can auto-instrument. Controller with sufficient licenses for the additional agents that we'll be utilizing. An agent access key for access and communication with the controller. A local user in the controller with server monitoring administration role, sufficient cluster capacity to launch a new application, and ensure that you have specified a unique app, tier, and node name within the YAML file that we're going to be using to deploy the application. We're going to next jump into a demo. What we're going to do here is we're going to show you how to configure the auto-instrumentation within the cluster YAML file. We've got a simple application called Pet Clinic. Actually, there's a few of them in there. There's a sock shop and a pet clinic, but we'll focus on the pet clinic. And what I'm going to do is I'm going to go ahead and edit this file that I made at K8's demo file for this particular recording. And we'll walk through it and take a look at it. This file's been dummied up with information, so this is not actual information. But this is the way it works. You've got some metadata up here, the namespace that the cluster agent runs in, the name of the actual cluster. And if we look at the spec part of the YAML file, the app name here, this is the name of the cluster when you see it in AppDynamics. So when you go into server and go into clusters, you're going to see this name. This is the name we're deploying to. This is the URL endpoint of your controller. This is your account name. You all should be pretty familiar with that. This is the image that's being pulled for the cluster agent. You can see we're pulling the latest image every single time, and that's what's going to be deployed. This is the service account that's being used, and these are the namespaces that the cluster agent is going to monitor: kubesystem, AppDynamics, default, pet clinic, and sock shop. You can change this to any pattern that you'd like to. I've just exposed them all for the sake of a demo. So this first top part is just really for deploying the cluster agent. If I snipped all the rest of this code out, we would get the cluster agent deployed, but no instrumentation to applications. The second part of this YAML file here for auto-instrumentation, we're going to walk through this as well. We're going to focus on the top application here, Pet Clinic. When you auto-instrument, you say instrumentation method is env. You set up the namespaces that you're going to monitor using regex, in which case it's Pet Clinic and sock shop. And then here's our instrumentation rules. So namespace regedit pet clinic, I'm going to name the app Pet Clinic-Kubernetes since it's running in Kubernetes, and we'll come back and talk a little bit about the options for naming applications in a second here. It's going to be instrumented with the Java agent, which is located here in our Docker Hub repo. Again, pulling the Java agent latest image. It's going to be mounted there. And that's pretty much it to auto instrumentation. We're doing it namely in the namespace. We're using manual name for the app name. There are several options here. You can name it manually like we've done it here using app name or using default app name. You can actually let it pick up the name of the namespace. Many times applications are deployed in separate namespaces, so that could be a good strategy to use, is just using the name of the namespace. The third is using a label. A label is a value that refers to a label in a workload spec, like for an application spec. You need to specify, app name strategy label, and then app name label, and you would specify, the label in that spec that you wanted it to pick the name up from. In this example here, again, we're just using manual naming. And that's pretty much it for reviewing this configuration file. And we're going to go ahead and go into the deploying the application as the next step. All right, now let's head off and deploy the Pet Clinic application as we talked about earlier. I've got a short script in here that we can use to start the demo up. Basically, it creates a namespace. We've already got one there. We're going to go check it, make sure it's clear. It's going to deploy this deployment using this particular image here for Pet Clinic. And off we're going to go. So let's go ahead and start the demo. And we're going to get an error that the namespace already exists, but it's going to go ahead and deploy the application anyhow. I'm going to go into a utility called K9s because it's quite fascinating to watch how the agent gets loaded into the Pet Clinic application. Here's Pet Clinic right here. You basically can see it's doing an init container. And if we go into it, we're going to see the agent attaching itself to this particular pod, which starts the instrumentation process and communication with the controller. So this is a cool little utility. I've got this from one of my customers that was an SRE, and I use it all the time because it's sort of like a cheat sheet for kubectl or a fast way to get into kubectl. Some of the other things this can do is if you wanted to just quickly look at the logs, we can see the application still starting, so it's going to take it a while to start. At some point, it's going to load the Java agent, but it's quite a cool little utility that can help you out on Kubernetes. So what we're going to do next is we're going to go to the controller and look in the controller and see that Pet Clinic has been deployed. And before we do that, I'm going to go offline on the sidelines here and basically put a load generator on top of this so that we get some data into AppDynamics and we can actually see it. Hi, now we're over to the AppDynamics GUI. As I said earlier, I've put a load on that application and let it warm up for about 5 to 6 minutes so that we got a nice load going on in there. Let's go ahead and navigate to the cluster agent, and we'll see some details there about what's going on. It's under servers and then under clusters. And in this environment, we've only got one configured. Let's go ahead and go into it. We can see on the dashboard there a lot of useful information about monitoring the cluster and some of those things. If we go into pods, we should be able to see our Pet Clinic pod down here as part of this deployment. And we can definitely see it down there. What we can do once we get to the pod, let's just go ahead and show you some of the functionality here. We're going to go ahead and search for it. I'm going to go into that particular application pod. We can see we can get a little bit of information out of it in terms of the app name, the pod hash. But the more interesting thing is taking a look at the container. How much CPU is it using? How much memory is it using? And then what we can do from this screen here is we can actually go from the cluster agent monitoring back to the APM and see that Java agent that we auto-instrumented is actually working. And we got a nice flow map there going on in terms of this small little application called Pet Clinic. We can actually go look at the containers from here too. Since we've got server viz loaded, we can actually go look at the containers, which you can see it's the same ID and same name as that we saw before. And that's it for our demo. Couple closing thoughts here is using the auto instrumentation with AppDynamics is fairly straightforward. It can get complex in terms of if you want to instrument a lot of applications, or if you want to do something pretty fancy. There's some things in there that you can use to do that really well. And then secondly, when you do get it all instrumented, the container or the pod is correlated right back to the application as we saw when we just deployed it there. I want to thank everybody for joining, and we'll see you next time.